Okay, thanks for that, Yannicka. Good morning, good afternoon, and good evening to our global colleagues. My name is Homayoun Vahidi, and I am Mott Macdonald's Transport Technology Lead for Canada. We're very excited to support ITS Canada with this webinar on digital twins and ITS. Most of us have heard and probably used the term digital twin over the last few years. And I believe that within the ITS community of transportation technology professionals, we wonder, or at least I wonder, exactly what a digital twin is. How is it different from some of the sophisticated transportation models we've used over the last couple of decades, or wondering how different a digital twin, for example, is from a highway traffic management system that uses sensors to measure traffic flow and detect incidents and control traffic. In this context, the auspices of this webinar was to provide the ITS community with some clarity on what a digital twin is, what are its underlying technological pillars, what are some of the current use cases, what are some emerging use cases, what are some challenges and trends. What better way to accomplish this by bringing together leaders and experts from industry, government, and academia in a panel format to shed light on this topic. Without further ado, our panelists include Dr. Lina Katan from the University of Calgary, Professor Bilal Farooq from Ryerson University, which is where I graduated from, Mr. Cyrus Tehrani, the Chief Digital Officer from the City of Hamilton, Mr. Rafael Villarreal, the Director of Transportation from the City of Surrey, and Ms. Jessie Adcock, VP of Digital at Finning, and Mark Enzer, the Chief Technology Officer from Mott Macdonald. Our agenda for today, if we can go to the next slide, includes a keynote presentation from Mark Enzer on digital twins, followed by a brief introduction and overview from each panelist, highlighting their interests in digital twins, its relevance to their mandates and their aspirations. And we'll follow that up with a Q&A session between the panelists and hopefully with a very engaged audience from the ITS community. From a housekeeping perspective, the webinar format does allow you to provide questions in the questions panel of the interface. So please post any questions that you have, and we will try and answer as many of them as we can in the time that we have. So I'm very excited to be surrounded by this group and excited to learn what I'm about to learn, and hopefully you'll all feel the same. I'll hand it over to Mark. There we go.
Thank you very much. I'm hoping you can hear me and see my screen okay.
Yes.
Fantastic, fantastic. So yes, thank you very much indeed for inviting me. It's a real pleasure to be with you and to share some of the stuff that we've been doing in the UK around digital twins, and maybe more particularly connected digital twins. I'm the current head of the National Digital Twin Programme in the UK. We're actually in a transition this year, so things are changing, but for now, I'm the head. So what I'd like to do, quite briefly, is introduce what a digital twin is, and then talk about what are connected digital twins. Talk a bit about why it matters, give some context for it, and then at the end, give a very brief overview as to what the UK has been doing about it. So let's kick off with what a digital twin is. And I think a good place to start is with the idea of an information value chain. So I'm sure that this will be very familiar to you. You know, the whole idea of bringing data in from many different sources, but recognizing that that is just data. You need to do something with it to make it fit for use, which might be about structuring it. It might be about applying metadata to know what you're dealing with, but it's still just data. And then we have to do something useful with it. We have to make sense of it. And we can imagine all sorts of analytics in that middle layer, helping us to make sense of the data, which then generates insights. And it's clear that the insights have a higher value than the original data on which they're based. And then we can use those insights to make decisions. And that's really the key, I think, in this whole information value chain. It's about making better decisions faster based on better data. And then if we make better decisions, that can drive better interventions, and the better interventions can lead to better outcomes. And so what we have here is a direct link between the outcomes that we desire and data on which decisions are made. And like I say, decisions are right in the center of that. Making better decisions faster is what releases the value. So if we kind of get that, which is really not to do with technology at all, it's to do with information, then we can see that information value chain embodied in a digital twin. So let me introduce digital twins very briefly and use an example which I guess is familiar to many of us, that of Formula One racing. So we're very familiar with the physical car that buzzes around the track at great speed, but then we might be aware that there's a digital version of that in the pit lane, and that digital version is being fed constantly by data. The physical car is bristling with sensors feeding data into the digital version, and that digital version is helping to generate insights. And based on those insights, which might be insights to do with when is the right time to bring the car in for a tire change, it could be to do with engine management or fuel management, but based on those insights can make decisions, and then the decisions lead to interventions that have a bearing in the physical world. And so this is really the essence of the digital twin, a kind of a connection between physical and digital, with data going one way and interventions going the other. Hopefully leading to better outcomes. And so you can see that information value chain that I talked about being wrapped around this digital twin. So if that's a basic digital twin, we can generalize it and just say that digital twins are this kind of connection between digital and physical. I mean, effectively, they are cyber physical systems. It's a connection between digital and physical. Now, if we want to apply that to the built environment, we can actually see that there are many different types of digital twins that are possible. But something that I think unites them all is this thing about delivering better decisions faster. That's kind of core to what they're about. It's core to their purpose. And we can see that we can potentially have digital twins of assets and processes and systems. So processes might not seem that physical, but they're kind of in the real world. We can certainly imagine digital twins of processes. And then within the digital twin, we see that there's something to do with managing data, there's something to do with modeling, and there's something to do with visualization, so that humans can have a look in and see what's happening inside the digital twin. And we think that digital twins really need to be driven by purpose. Because otherwise you kind of get into this situation that technology without a purpose is just a toy. And we can see in digital twins really that they're a means of integrating technology rather than just being a technology by themselves. And what I mean by this is that we can see around a digital twin how you can bring together sensor technology, IoT and 5G to get data into the digital world, how you can use AI and ML in the sense making, and how you can use visualization technologies to help people look in and see the digital twin. So I've been pretty quick in running through that, but what hopefully that shows is the essence of what a digital twin is, and then we can start to apply it in the real world. So let's do that and see how you could have an individual digital twin of a train, helping to make better operational decisions. So hopefully the train would never break down. And so if we look at that individual digital twin of a train, we can also potentially imagine digital twins of the track, of the signaling. And we know that in the real world, those are physically connected. And I think when we start to consider connected digital twins, what we're talking about is making the connection in the digital world between the digital twins. And this is what we mean by connected digital twins, which enables us to start understanding systems better and intervening more effectively. And we can take that up a level and think that if we've now kind of connected together some digital twins around rail transport, you could imagine the same thing around road, similar thing around air. And again, in the physical world, these are all connected. So now we can think about connecting them in the digital world. So we've moved now beyond just connecting digital twins, but starting to imagine an ecosystem of connected digital twins. In this ecosystem, if the world was just technical, that would be nice and easy, wouldn't it? The reality is that in between these, there are organizational boundaries. And I'll come back to this briefly because we see this overall program as not just being technical, but socio-technical, because we need to address human and organizational factors as well as technical. But now I've introduced this whole idea of digital twins, connected digital twins, an ecosystem of connected digital twins. There's a whole question of why it matters, what's it all about? And for that, I would want to take a step back and see our built environment as an amazing system of systems, joining our economic infrastructure, social infrastructure, and interface with the natural environment. Each layer is amazingly complex and interconnected, because you can imagine just transport is complicated enough, but then it's connected to telecoms and to energy. So you can see that this is an amazing complex system of systems. And what we really want to do is understand those systems and intervene more effectively. And that's how we see an ecosystem of connected digital twins. It's really a tool to help us understand and intervene more effectively. Now, why does this matter? And the next slide is intentionally provocative, but I want to make a point, and that is that oh no, sorry, my next slide is coming after this. So what we see in this system view is lots of different digital twins which can be joined up to help us understand the systems better and intervene more effectively. So the following slide is my provocative one, and the reason for putting it there is really to make a point that these systems level understandings and interventions are really important, and that's because we face massive system level challenges. So to be able to address climate change, to be able to achieve net zero, to achieve climate resilience, to achieve circular economy, to address biodiversity, all of these are system level challenges that demand systems-based solutions. So we really do need to understand the systems better and intervene more effectively. So this is kind of urgent, but thankfully we have these tools now at hand that if we develop them properly, then we can bring them to these challenges and have some hope of making sensible choices. So I'll just touch now briefly on what the UK is doing about this. I'd like to start by pointing to some flagship policy. This has come out recently, called Transforming Infrastructure Performance. I'd commend it to you. It's a really good visionary bit of leading policy. But what this shows is that same pattern that I described of a focus on outcomes, recognizing how an information flow can lead to those better outcomes by making better decisions, better interventions, all based on systems. So it's kind of built into policy. Also, a number of years back, there was this coming out of our National Infrastructure Commission that recommended moving towards having a national digital twin. Again, I'd commend this report to you called Data for Public Good. And really, this has guided us on the programme so far. What it also recommended was that we should establish an information management framework to help with that connection between digital twins. And what that really comes down to is interoperability. It's about federation. It's about having a semantic precision that enables the secure, resilient information flow across organizational and sector boundaries. And that's kind of at the core of being able to connect digital twins. The essence of it, I won't go into the detail just because we're short of time, but the essence of it is having a consistent approach to data modeling, having shared reference data, and having common security and access protocols. We think that if we put this in place, then we can help to get that interoperability and the connection between digital twins. And we can move towards what I keep emphasizing, understanding systems better and intervening more effectively. We see the overall program not just as technical, but as socio-technical. And this is because we need to address those organizational and human factors. We have become more and more clear that this is not just a technical problem. We have to address things like the ethics. We have to address skills. We have to address commercial, legal, and regulatory solutions. You know, some very human things in order to make all of this happen. We felt from very early on that we needed to be guided by principles and publish these Gemini Principles, another document that I would commend to you because we felt that the whole program needed to be built on firm foundations of principles. And when it comes to the actual program, I'll be very brief, but just to touch on three key components. One is our digital twin hub. This is establishing a community of people who are interested in digital twins and connecting them both on the demand side and the supply side. Credo is our demonstrator project. We chose climate resilience to demonstrate in a tangible way the benefit of secure information flow across sector boundaries. We chose a scenario relating to water, energy, and telecoms. We produced a film which, again, I'd commend to you. It tells a story in a really accessible way as to why this is so important. And we've developed a very easy to follow story that basically indicates that if you only have access to data about your own assets, you can make certain resilience decisions. But if you can also have access to data about the assets on which yours depend, then you can make better resilience decisions. If you're a water company, your assets depend both on telecoms and energy. So you kind of need to know in order to make better resilience decisions. So that was a very, very quick scoot through. I hope you've got a sense of what digital twins are, what connected digital twins are, why it matters. And I guess what I would want to leave you with is this thought that a national digital twin program does need to be outcome focused, does need to be purpose driven, does need to be systems based, values guided, and socio-technical. So thank you very much indeed.
Thank you, Mark. That was a great crash course into the topic with a lot of interesting and resonating points that I'm going to refer to after when we get into the panel discussion to initiate some questions. But sticking with the agenda for now, I think we're going to go to the introduction of the panelists and a bit of an overview on their interest and aspirations on this topic. So Cyrus, I'll hand it over to you for your introduction and commentary.
Thank you. First of all, thank you for having me on this panel, and Mark, great presentation. I feel like I learned a lot. I feel, hard to follow that act, but I'll do my best. I'm going to be just speaking from more of a municipal concept. So first of all, introductions. My name is Cyrus Traney. I'm the Chief Digital Officer and Director of Innovation for the City of Hamilton. The region of Hamilton is around the 9th largest municipality for our international visitors here. We sit on the western edge of the Great Lakes, sort of west of Toronto, north of Buffalo. And in my role, I have various responsibilities, including our smart cities portfolio, our open data portfolio, corporate initiatives and corporate partnerships, and a program called City Labs. So we're here to talk about digital twins. And I think from a municipal perspective, there's a lot of interest in understanding how digital twins can support the operations and service delivery models that municipalities do. And as a tier 1 municipality, so again, Hamilton is a tier 1, we look after everything from cemeteries to golf courses to water to transportation to roads to traffic. you name it, public health, it's all within our sort of domain. So the amount of data that a city has is pretty broad. It tends to be siloed in disparate data systems that are used to support the operations of the various divisions and the service deliveries that the city carries out. So one area of, we think about this definition of a digital twin is not only this sort of idea of having a model that shows all this information, but having real-time information, as Mark referred to, feeding into the model and understanding it. So if I take a step back from that and just talk about municipal use cases, and I'll give you some practical examples of development towards, and I think it's important to mention, I think, digital twins, I see them in my perspective, and this might just be mine, is not something that's really, it's not something you go out and just procure. It's a systems and a process that you build layers on top of it to get to a point where you have some representation of the actual world. So from a municipal perspective, again, if you think about the positive impacts, I think one area that's seeing a lot of evolution is on the environmental side. And again, that was alluded to. But if we think about modeling a region's energy usage and our journey to decarbonization and net zero, it might be a slightly different twist on, we're not thinking about a 3D model with VR glasses that we're rotating around and looking at, a twin of the downtown area of the whole region, but we're more thinking about a twin of our consumption and our sources of use around different sources of energy and what their impacts are both environmentally and where the opportunities are that lie around decarbonization as we move towards those targets. So I think digital twin technology to support decarbonization and the environment is a key area of interest. This is an ITS session, so I would be loath not to speak about, traffic. And if you think, I know from an observer, cities like Chattanooga, I think have done some exciting work around creation of digital twins where they've taken multiple data sources, whether it be traffic information from their traffic systems, their 911 data, radar data collection, LiDAR, and put it all into a model, which they've also, I think, made available for research purposes. And they've shown just through their modeling that they can see potential for up to 30% reduction in congestion and improved traffic flow through the use of these models that take in multivariable inputs. And that's an interesting finding in terms of what is the impact both to quality of life, so those socioeconomic factors of your commute times and your impact of traffic, but also the environmental side of if you can reduce congestion, you're also implying a reduction in GHG and less consumption of fossil fuels, at least while we're in a majority ICE integrated combustion engine technologies for vehicles. We see other regions like Las Vegas is pushing hard on a digital twin. At Hamilton, we've done some work around creating a digital twin and a 3D model of our downtown core, so that as new development projects come up, they can be 3D printed and put into the model, as well as using spatial solution tools to understand. You think about a city, you get a building permit. As part of that building permit, you're getting electronic building plans, being able to take those electronic building plans and then interject them into a model that you may already have of a specific region. We're a rural and urban mix, so it's not about modeling the entire 1,600 square kilometers, but specific areas where now you can start to see things around, how does building height impact wind flows or sound, or even more so maybe from a council perspective and a planning perspective, what does that mean for shadows and impacts to building design around the neighboring planning space, I guess you could call it that. And I don't think that's rocket science. It's about using and starting slowly on that journey. I think also if we look at collecting data, so one example that's a little bit on the maturation path or the startway path is, we have combined sewer overflow systems here in Hamilton, and creating real-time monitoring of those to be able to present them publicly for information purposes. So that's not a full digital twin of the entire sewer and water infrastructure, but it's a component of that that can be used to convey information to the public that may have interest of it by combining both models and sensor technology to indicate real-time status of information. We've used cases where, for example, we're doing some rehabilitation work on a local creek, and we use LiDAR drone technologies with LiDAR mapping to create the current state. You know, you think about some of the evolution of technologies around drones, and I'm going to probably say this wrong because I'm not an expert. I think it's called bathymetry, or I might have that term wrong, but the ability to take a drone with a sensor and drop it into a stormwater pond and use Doppler or other types of radar technologies to define what the profile of the stormwater retention pond may look like, to then easily identify where does rehabilitation have to take if you're thinking about buildup in the pond and maintaining the ponds as part of storm management and overall resiliency across the city. And I think, as we see technologies, whether it be, I don't want to harp on drone technologies, but advanced LiDAR, point cloud mapping, photogrammetry, we're exploring right now an opportunity where we do a shutdown of one of the major transportation arteries that goes through the city, and working with our post-secondary institution, Mohawk College, to make a portion of that highway infrastructure available during a shutdown so that they can collect information and make it really a 3D twin model of an intersection or a portion of the highway, such that then it can be used as educational purposes for their students to understand the design of cloverleaf ramps and road pitch angles and bridge structures and things like that. So again, maybe not, it's an evolution path, I think, for municipalities as it relates to the use cases for digital twins, but there's definitely a lot of opportunities, and it might be an incremental progress of, building those models versus starting out with a full, urban 3D model of an entire city with all the various systems in it, because that's just not something it's manageable or doesn't align to that whole use case of what problem are you trying to solve with digital twins, and pursue that rather than just creating a digital twin for the sake of the technology. So that's a bit over 8 minutes. I hope that insight was informative, and I'll pass it back.
Thanks very much, Cyrus. That was great. And your point on decarbonization as a key use case, I think, still does tie into ITS, because ITS is an enabler of dealing with some of our climate challenges, and I'm sure this topic we'll talk more about that. And next up, we have Rafael Villarreal from City of Surrey. Rafael, I'll let you introduce yourself and maybe give us an overview in terms of interests and aspirations on this topic.
Great, thank you. Good morning. I'm speaking today from Surrey. Surrey is kind of the second largest kind of municipality in BC, and probably 10 years it's going to be probably bigger than Vancouver. We reside in the on-city territory of the Semiahmoo First Nation, Katsia, and Kwantlen First Nation. So I lead the transportation division in Surrey. It's a fairly large group. We have like 6 different kind of sections. So it's very multidisciplinary. And my background is engineering, but also urban planning. And I do have quite a bit of a background in GIS and data, so I'm fairly passionate about data. So today, if I notice, I don't have the slides, same as, and well, slides are a lot of work, but also people tend to multitask in these virtual events. So I don't expect you to be multitasking, but I hope at least you get some information in listening mode. I believe that we're kind of ways ahead to have a rigorous foundation to take full advantage of a digital twin. And I'm not talking about the city of Surrey, my city. I'm talking about overall Canada. We're kind of behind if we compare ourselves with what is happening in the rest of the world. But we got to start somewhere, right? So today I want to reflect in 3 key points. The first one is develop a culture of data and a culture of digitalization. So what feeds the digital twin and digitalization is data. Second, the concept and the practice of intelligent infrastructure and how it needs to be ingrained in our traditional civil engineering practice. I think sensors and digital systems need to work together with hard infrastructure. I need to be at the core of hard infrastructure. And there's a lot of work that needs to happen there. And 3 is that the path ahead starts with strategy, capacity building, and working across disciplines. So we need to develop a culture of rigor, data, multidisciplinary collaboration, and sustained advancement with small wins. Again, not quick wins, is different. Small wins that take us kind of to where we need to be. So let's just get started. First, develop a culture of data and a culture of digitalization. So when I heard that kind of in many contexts, it's like usually when you get to a new place, they tell you, oh, we have a lot of data. We have traffic cameras that are capturing data, traffic movement data all over. So we have tons of data. But when you validate the data is not necessarily good enough. It's data that is very dirty. So one thing to be clear is like having data might not be enough. We always have to make sure that that data is validated and you have properly calibrated sensors. Because data really is the food for digitalization and for digital twinning. But data needs to have statistical validity. So it's critical to know what are the strengths and the limitations of our sensors and the data that we are collecting. And data comes in many shapes and forms. And for instance, like we have cameras, we can have sensors, we can have now external mobility providers, we can have vehicles kind of sending data, and we have a lot of activity or even land use related data. But at the end of the day, it's about how do you start blending of the data together. And it's actually not that simple. And it's not that simple even to know the quality of the data that you have, but it's fundamental as you build kind of your models and you start to get to the really important thing of digital twinning, which it is getting to those complex questions that require this blend of many sources of data and dimensions, which are questions about equity and inclusion and climate change. We can also get insights about traditional infrastructure health and operational efficiency, but the reality is like all these sources of data working together is what it gets us kind of to some of those good insights. But again, data is expensive. So we need to start working towards some data frameworks, but not just kind of collecting data, but also like how we're gonna fund actually this constant influx of data. So data frameworks are critical. Second, the case and the gap for intelligent infrastructure. So there is a story, like 3 years ago, the city completed this signature active transportation project. So like a few weeks ago, I was asking, guys, do we have any sensors kind of to see how it's been the utilization of our new corridor? And the answer was like, oh yeah, we do have sensors. So I asked, where's the data? They're like, wow, well, we haven't processed the data yet. And it's not a criticism to my team. It's like, it's very common that sometimes you put sensors out there, but you don't really have together how you're going to be using the data, how the data kind of translate into decision making. So there's a lot of work that we need to do, as I said, between kind of intelligent infrastructure and the practice of engineering. So it's adding these sensors and digital systems to our hard infrastructure so we can start evolving our models from our traditional kind of 3-dimensional models to like 7-dimensional models. So we can add time data, we can add cost data, we can add facility and asset management, utilization data, and then also sustainability and equity evaluations. All that has to be somehow integrated in some of the projects that we're working on. So I really think we need to reflect on our hard engineering practice. And I don't think we need to have all the answers right now, but we need to start thinking of how to address some structural issues right now that we have when we think about infrastructure. So we need to start thinking about how those sensors related to infrastructure health can be part of our infrastructure projects. And not just kind of utilization, but inside of some of the materials that we have, right? So weather or air quality conditions, so we can start fitting our digital twins, but again, not just to have fancy models, but also to help us to have some kind of some concrete and good insights of what is happening. So I think there's a long path ahead here. The deficiency in thinking and acting towards intelligent infrastructure is a national problem. And I think, like I said, we're really behind compared to other countries, and some work needs to happen here. And this work probably starting kind of with the municipalities. So 3, capacity building and working across disciplines, I think is the path ahead. So for instance, in Surrey, I think we have one of the strongest GIS team in the country, and I'm pretty proud of our GIS team. We have a brilliant staff managing kind of one of the most advanced traffic management centers in BC and probably in the country. And we have, let's say, a data-driven Vision Zero road safety team that works with a lot of data. But all these 3 are within the same transportation division, But however, the formal co-creation between this group wasn't necessarily clear. And if that's in the same city, I cannot imagine how it is kind of when you start going outside. So there's a lot of work that needs to happen across disciplines. So we need to start with a strategy and then build capacity to develop this culture of rigor, data, and sustained efforts and small wins. I want to differentiate here small wins versus quick wins, because quick wins sometimes get us to awards, but doesn't really get us kind of to really what we need to get. And we have to be careful with that sometimes, because there's a lot of talk and marketing around digital twins, but what is the substance? And I think the only way kind of is with rigorous data and co-creation between disciplines. And it's not really a silver bullet. It's a lot of effort, a lot of building kind of this data. So everything starts with data. No, really starts with strategy, and strategy helps us to build a culture. And strategy and culture, not technology, really is what is going to drive the transformations that we need. So some takeaways, kind of getting to the end, is digital representations are the future of engineering and city planning. It's already happening in many other areas. So it's not just kind of in city planning. So it's not different in our business. But it really requires going beyond this sexy idea that we usually have of a digital twin with award-winning, good-looking by shallow renderings. It's going to the next level. Things that might not be sexy at the beginning, but then will drive kind of some of the decisions that we need to make. So it's really rigorous connections between disciplines, smart infrastructure, service providers, patterns, and societal behaviors, such as demographic information, multiple disciplines working together on a common platform. So the result is a model with infrastructure assets, people behaviors, let's say collisions, mobility patterns, and much more. So in summary, I want to summarize kind of the presentation. First, that is the core of digitalization. And therefore, digital twinning needs rigor and statistical validity. So we know the strengths and weaknesses of our data, and we can be transparent when we compare and blend data sets from many different sources. Second, we have a long path ahead to evolve our engineering practice toward intelligent infrastructure. So it is okay to question what sensors are we adding, what are we going to be doing with that data, what tools do we need, and how do we use those tools to monitor hard infrastructure. And three, there are not really silver bullets or simple formulas. I mean, let us be open. It's about rigor, small wins, but continuous small wins, and not quick wins just to chase kind of the next award. It's really kind of a lot of work. And it's with discipline and sustained capacity building within our teams that we will evolve to a meaningful use of data and digital twinning. Thank you.
Thank you very much, Rafael. That was a great way to structure the commentary in terms of those three driving points, and very complementary to the use cases that Cyrus provided. So great insight in terms of from a municipal perspective. Now we'll change gears to academia, and it's my pleasure to introduce Professor Bilal Farooq from Ryerson to give us his thoughts on this topic, but through a different lens. Bilal?
Thank you, Homayoun. My name is Bilal Farooq. I'm an associate professor in transportation engineering in civil engineering department at Ryerson University. I also have a Canada Research Chair in disruptive transportation technologies and services. In terms of digital twin, I think the first serious interaction with digital twins, it started around when I was doing my PhD about 10 years ago, where the focus was on simulating our urban areas. So as part of my PhD thesis, we simulated the entire Greater Toronto and Hamilton area with 6 million, about 6 to 8 million agents or people, and their transportation habits, their usage of transportation infrastructure, their land use patterns, their environmental emissions, and so on. So it was an integrated transportation, land use, and environment simulation. And I think the focus there was on developing a very realistic models, mathematical models that can be used for developing the simulations of these systems and their interactions. And I would call that an offline digital twin. And what was missing from those sort of efforts and what is going on today is the introduction of sensors, communication, the visualization, more powerful visualization, and also the interactivity. And just because of that, the digital twin has moved more towards real-time domain as well, and that's what I'm going to focus on in what we are working these days. In particular, I'll point out one project that where we are utilizing digital twin in its all glory, and that is to better train automated vehicles in urban environments where the complexity is much higher than, say, on highways or any other locations. And here, what we started a couple of years ago, after looking at what's going on with other AVs that are commercially available and how they are being trained and what kind of outcomes they are coming. You see these accidents and so on happening, and so we looked at what is missing there, and how is it that these sort of incidents are happening. And even if you see now, for instance, you might have seen the Tesla FSD's videos these days, how they are being driven in the full self-driving mode, and how clumsy the whole movement is. So for that, what we tried to do was that we created a digital twin in our lab, and I think as a transportation engineer, we are pretty good at modeling the movement of vehicles, pedestrians, any object that is on our road networks and on our streets. So we made sure that we are coding those models very realistically, and then we also brought in virtual reality, and with that virtual reality, we hooked a human in the loop. So our simulation is now in real time, where a real human can actually interact with our simulated objects. And you see top right. Okay, so you see on top right that humans as pedestrians, humans as a passenger in a car are able to experience that digital twin, and their actions, there are reactions to their actions, and so for instance, if another pedestrian is coming in, a virtual pedestrian is walking and you come in their way, they will try to avoid you, just like you would see that in a real environment. And what we did with this was that we actually trained a virtual AV related to these scenes where the pedestrians would try to cross the road, and the incoming AV would try to plan their paths according to the movement of the pedestrian. And with that, what we see is that we were able to bring in the context that is in there, in terms where the pedestrian is looking, how they are walking, whether they are walking with a friend or alone, or they are walking in a very dense urban area where there are tons of pedestrians, or there are other vehicles as well. And with this, the models that we produced, they perform much better than, for instance, the model that we developed on the open access data that is available through Waymo or Lyft previously, and a couple of other open access data sets that we tried as well. This seems to be now a trend in AV industry as well. You might have heard about a couple of days ago, Wabi introduced their digital twin, where they are trying to simulate the different environments and trying to train their vehicles within their simulation. Similarly, companies like Aurora, Too Simple, they all have moved towards digital twins, where they are trying to train their vehicles in that environment, because all the cases, all the complexities, they cannot be just covered by running your vehicles on the roads. There are some complexities. There are some cases, many of these edge cases, that you need to reproduce in simulation, where you need to train your vehicles. So this is one of the applications that we have been working on. Some other applications that we are working on are related to routing, especially eco routing, multi-objective eco routing, in the sense that guiding vehicles in real time through the network in a way such that not only we are trying to minimize the travel times for the vehicle, but also trying to minimize their greenhouse gas emissions, because greenhouse gas emissions, it has a non-linear relationship with the speed of a vehicle itself. So we try to take that into account as well. So these are some of the applications that we have been working on in digital twin. I'll stop here, and if you have any questions, please feel free to ask.
Thanks very much, Professor Bilal. And yeah, just as a quick reminder, I've noticed that a few questions have come through, which we look forward to getting in to discuss. But if you do have any questions, please use the question box of the webinar dashboard. And now we'll go to Dr. Katan from University of Calgary, and it would be great to hear your perspective on this topic.
Thank you, Homayoun. This is Kina Katan. Thanks for having me today. I'm really enjoying the presentation. I'm a professor in civil engineering at the University of Calgary. I'm also the director of the AMA Active Traffic and Demand Management Laboratory. Currently, I'm leading an Enzer Create program on integrated infrastructure for sustainable cities. So very similar to the concept that Mark has introduced about considering systems of systems and several urban infrastructure in the city. So the research interests that I conduct so far are mainly using offline traffic simulation. This means you take the data from the sensors, the historical data, and you calibrate your model in order to do a bunch of research ranging from traffic and demand management, with a special focus on connected and autonomous vehicles. So mainly focusing on urban congestion mitigation and also transit operation. The second one is large-scale network modeling and analysis, which are mainly data-driven. So looking at large-scale network vulnerability analysis and resilience analysis, network evacuation, congestion pricing, and also where to locate sensors, like optimum sensor location to improve the online monitoring for the transportation system. The third one is more data-driven demand estimation prediction model for multiple modes. So benefiting from the wealth of information that we get from GPS tracking and index data and so on, we try to find the time-dependent origin destination movements of various modes in the city. And the last one is the integrated infrastructure program. It's Enzer Create program, which is a transdisciplinary research team consisting, led by the University of Calgary, but also by 3 other universities, Waterloo, University of Victoria, and UBC, and also international universities like Hong Kong and Leeds. And in this, like, we really try to understand the impacts and the long-term impacts of innovations and technologies on various urban infrastructure, and how to steer these innovations in order to meet the long-term sustainability aspirations of our cities. Next slide, please. I've been asked to talk about emerging trends and research. I think the most important disruption that we're facing as humanities, I would say, is climate change. And most of the time, we put innovative technologies as the antidote in order to, address the issues of climate change. So under climate change, for sure, decarbonization and meeting the Paris Agreement is very important, and transportation is responsible for 25% of emissions and pollution. So it's really very important to look at sustainability issues within transportation. With rapid urbanization, we have increased pressure on the transportation systems and delivering, goods and accessibility to the basic services. And also with extreme events, we have also great pressure on our transportation infrastructure. So our research related to network resilience and vulnerability is very timely. To meet the UN 17 Sustainability Goals, equity and fairness are becoming emerging trends in transportation, and that needs to be addressed. So the other disruption is, like, as we said, is most of the time we look at it as the cure in order to address climate change. We have to be careful, because we always have to look at the long-term impacts, because like sometimes we can find quick solution, but on the long term, we should look at the system perspective, so more integrated perspective to examine the long-term implications. And we can no more look at transportation in isolation, because we're talking in the future about electric cars and connected vehicles. And so this is going to be really so much interacting and intertwining with other infrastructure like the electric grid and wireless network and so on. The other issue is, because everything is, the cyber security issues and the security issues, and for sure the safety issues, and everything is real. It's not like really, we are not really dividing them, because they are so much overlapping. So the next slide, please. Yeah, I believe most of the research conducted so far in the transportation is really looking at offline simulation. Most of them, like the majority. So with digital twin and with the new data collected from, the devices, the sensors, the cars moving, and more in the future, we have this partial real-time feedback capability. And this can elevate our research agenda and move the ITS and the connected and autonomous vehicles and agenda to the next level. So for instance, we can really assess the changes in the demand, which is very difficult today to do, because we can only, infer through mobile, like through most of the time, fixed sensors, how the demand looks like. But with digital twin and having this real-time constant connectivity between the physical and the digital, we can see the within variation of the demand within the day and the day-to-day fluctuation of the demand. So the impacts of our demand management and traffic control on how it's shifting the demand, how by mode or rerouting decisions, time departure decision, and even on longer term, like change in residence location. And also the other thing is like the need to do like online calibration, because you need always to improve the capability of your digital twin to mimic the physical system. So there's a need to do like this online calibration. With the plethora of data that we're collecting, we can also do real-time estimation and prediction of the state of the physical system, and try to predict where the problems are going to happen, and try to intervene and find and come with decisions to prevent the problems to happen. So such as like emission hotspots, traffic and congestion patterns, safety measures, because also ideally we will have access to trajectory data, right? So we can find even surrogate measures where accidents can happen in the future and try to intervene so we can prevent them. And with also this trajectory, we can get like lots of inferences about the behavior and the interactions between the various systems and various modes. I would say, like, also we are moving to have a new generation of performance dashboard, where it is at the same time it can be more system-wide perspective, because we can find, like, we can do network wide reliability, vulnerability, and resilience analysis. But at the same time, it can be more granular to get very important information about the societal impacts, such as accessibility of the system, the mobility, and equity. Yeah, and I think I'm done with my slides. Thank you.
Thank you very much. That was very insightful in terms of some of the areas of interest to you and on this topic. To close out our commentary and get into some of the question and answer, last but not least, it's great to introduce Jesse Adcock, who brings both public and industry perspective to this topic, and I think we'll round this discussion up very nicely. So over to you, Jesse.
Yeah, thanks. It's been it's really great to be here, and it's been really informative listening to everyone's different perspectives on this. I think we've covered just about most use cases right now that are sort of very prevalent and in use. I think we're at the cusp of probably infinity more, especially as we start talking about the link between digital twins and the metaverse, and how that might have a transformational impact as we move forward on shopping, buying, existing, consuming all sorts of media. So I think that we're at the, oh, I do need my slide up though. Thank you. So I do think that we're at the, we're beyond the point where we were a few years ago, where folks were figuring out what is a digital twin, and we're well into the utilization of it. I do believe though that depending on the use case, the actual manifestation of what is the twin can vary. I've had the privilege now of working both in private and public sector. I started off my career in banking, so became very aware of sort of what individuals would like in terms of experiential experiences through the transition of the banking model from analog to digital. I then moved into a role as the Chief Digital Officer for the City of Vancouver, followed by a role as your Chief Information Officer, and most recently I've been working in as Vice President Digital with Finning. And in all of those cases, as it pertains to twins, I've found a lot of similarities in that if we go back to Mark's opening keynote, that sort of pyramid of data and that drive towards insight and decision-making, which is ultimately, I think, what we're all trying to drive towards. In terms of, I think, interesting challenges, I mean, I think what I'd rather like to focus on to just close this out today are some of the practical experiences that I've had personally working in the number of use cases that we're talking about. Specifically, for example, just to give you an idea of the types of models I've worked with, I have worked with maintaining multiple different data models for the city. I was a general manager for development and licensing before I left the city, and so working extensively with planners, developers, et cetera, to work through various projects. As Chief Digital Officer, we utilize various representations of what could be for engagement purposes. And so some of the challenges that I see are consistent. Talent is going to be a very big challenge moving forward, just the skills necessary to both conceptualize whatever it is that we're using as the system. You know, in some cases, I think it's really important to impart that in some cases the twin might be just flat data sets that produce insight. In other cases, the twins could be 3D models, and there's going to be a spectrum of everything in between. Ultimately, what we're going to be doing is trying to make sense of data to make decisions. And I think the talent that is required for that is now talent that is highly in demand by every company, not just tech companies anymore, or governments. It's sort of all across the way. Once those technology models become more embedded in the way that we do things, the decisions that we make, we introduce all of the enterprise IT risk, right? Cybersecurity risk, we enter into all sorts of risk around just data modeling, integrity, management of all those things. I think model accuracy is a very interesting one that I would like to sort of touch on for a second. Now I've had the opportunity to work with some models, both in the context of development applications, and we've done POCs and pilots, but also as of most recently, working with a model on the HS2 project in the UK, where that is the largest earth-moving project in the world, and working with Finning using their Cubic platform, which is essentially a performance dashboard, and working with them. The accuracy of these models is really important and strictly tied to that decision quality. And so maintaining the models is going to be very important. So it's not, I think, like traditional decision enablers where we can sort of build it, use it for a while. A lot of these models are going to require regular update, regular maintenance, regular grooming to be able to continue to be applicable. And I think that is going to be accompanied by a significant amount of cost and oversight needs that I think we are probably at this stage, unless you've been immersed in the usage of these models, would be underestimating, I think, in terms of just how much it takes to run the models, because if we don't maintain them, they will run the risk of not producing the decisions of the caliber that we need. Mark, you touched on this with the system of systems, but the interoperability risk, I think, is going to be fundamental, especially when we start to take a step back. There is no singular digital twin technology. There is no singular digital twin methodology. There's going to, again, be a spectrum based on perspective. And so Mark, when you touched on that notion of organizational boundaries, I think the key thing is going to be, what is the system in one organization, within one organization's boundaries, and is it interoperable with the other? And I think where we have influence over network design, such as, like, if we take the automated vehicle, connected vehicle example, where we need a number of different parties to subscribe to a similar standard. But as you know, and this audience knows more than anyone, that is a massive ecosystem and a lot of players. The technology has been present for years. It is the bureaucracy of the interoperability that has prohibited the technology from becoming mainstream. And so I think, for us as a population, as we navigate through this sort of evolution of digital, that's going to be very, very interesting. Which brings me to the viability of some of these models. What I've seen is that there's a lot of energy in building the initial model, but it falls off a cliff afterwards when you have to think about the money that goes into operating it. And where is the money that goes into operating it? So I would say that some of the challenges that I've experienced have been around that, where there is an initial phase of energy and enthusiasm that then, once you start to see the reality of the challenges that I've listed, the kind of honeymoon wears off. So I would recommend to folks that are embarking upon endeavors where a twin is involved, to be able to think through the sort of total life of that asset, and then how is it going to be not only just built, but the subsequent phases of maintenance. Finally, I'll stop on dogma, because this was one of the interesting things in Homayoun. You and I had maybe some conversations about this back when we were working on the smart cities stuff together. But oftentimes, as is the case with anything of a technical nature, you do land on strong opinions. And so when we start to talk about those ecosystems, especially in the public-private realm, where you have that convergence happening of the digital realm, the physical realm, urban planning, what governments are doing, and long-term strategies, there are going to be a lot of opinions of a varying nature. A lot of the outcomes that we're seeking, I think, through the use of twins are things like environmental impacts, safety impacts, productivity, resilience, performance, the ability to be predictive. And in most of these cases, as we kind of cross those organizational boundaries in that ecosystem, not only is technical interoperability going to be important, but I think philosophical interoperability is also going to be very important. So that said, I think, you know, like you see in the middle of my slide there, is that we are in this transition where that distance between physical realm and digital realm is compressing even further and further. And so I think that what we'll see is, rather than this being viewed as an emerging technology, rather it'll sort of just become par for the course in very short time. So I'll just leave it there, and then I guess pass it over to Homayoun for any of the questions that you want to open up with the group.
Sure, thank you. That was great, and thanks for weaving the word metaverse in there. I'm sure everyone's thinking, now that we know what a digital twin is, we have to start thinking about what exactly is the metaverse. But maybe that can be a subject for a follow-up session. No, this is great. I think, you know, before opening it up, I do want to make the observation that you know, on behalf of the Intelligent Transportation Systems ITS community, we should pat ourselves on the back, because we literally have been doing digital twins all along at different scales. Thinking of Mark's very simple and clear diagram of data and intervention, when you think of a actuated traffic signal that detects a vehicle and adjusts the timing in response to the demand, that is that data intervention cycle at a very, very micro scale. Or even if you think of a computer-aided dispatch AVL system that a transit agency uses, that is a digital twin where they know where all their buses are, they have the schedule coded, they have the stations coded, and they can make informed decisions on how to dynamically change the service that the transit system has provided. So this is very interesting, because we really have been doing this all along, but what has changed is the computing power and the big data. There is so much more insight available now, and so much more processing can be done, that the scale of what we've been doing in small intelligent transportation system projects has changed to get to the network or the city level. And I think that is very exciting for this community, and obviously for us as a society. So with that, maybe going into the questions and circling back to Mark, one of the first questions I saw relates to both citizen engagement and the role of government. And I thought it would be nice to hear a little bit more about what has been the role of the UK government in the national initiative in the UK, and then maybe if the panel has any comments on where we think our federal government should be in terms of supporting some of the initiatives that we talked about.
Great, thank you very much. So yeah, I think both of those engagements are hugely important, the citizen engagement and the government. I think that there's more as well. I think that there needs to be a collaboration between government, industry and academia to kind of pull together in the same direction to do something good here. But the citizen engagement is super important, because I think fundamentally these digital twins and connected digital twins have to be trusted, because if they're not trusted, then they're useless. And so we have to build trust, and they have to be trustworthy, and we have to understand what trust is. And that really does mean proper engagement with people. And I think that if we are also minded that the whole point of this is to get better outcomes, then we need to decide what those better outcomes are. We think it's some kind of combination of environmental, social and economic outcomes, but what kind of balance? You know, there should be a kind of a democratic dialogue there to identify what kind of outcomes we're aiming for, so that then we can use these digital twins to try and get there. So citizen engagement is hugely important. When it comes to government engagement, I think that there are some specific things that government and only government can do, which are worth noting. And I think one of the main things is to do with preventing market failure. And I can see two main areas of market failure here. One is a failure to federate, and what this is all about is getting the right standards in place so that where we are trying to bring things together, that they meet. There is a danger that we get a Wild West in digital twin land and everyone does their own thing and they don't talk to each other. And what we really need if we're going to federate digital twins is that the digital twins can talk to each other. So I think there needs to be some kind of high level leadership to do something that the market alone can't do. And that's to kind of get these standards and approaches in place that enables the federation. And then what that will mean is that effectively we have a bigger pie. Everyone benefits from this kind of federation. But I think there's a second kind of market failure, which is really important in here, which is an ethical market failure. And this is all to do with whether the digital twins are good. Because digital twins, it's just an integration of technology, and that could be used for good or ill. And so you can imagine the exact technology we've just been talking about being used in dodgy ways, and we don't want that. So I think to prevent the ethical market failure, then what we need to do is make sure that ethics is built into this from the ground up. It basically loops back to my earlier point about the trust, and that's why I commended the Gemini Principles earlier on. That I think that if we're going to go down this route, we really need to make sure that digital twins are used ethically. That is an absolute essential, and we need to build that in from the beginning so that they start right and they keep right.
Thank you. That's kind of answers that from both sides. There's a question about cybersecurity, and that's something that was on my mind as well as I was researching for this discussion, and kind of thinking of Jesse's comment about how interoperability is so key when we want to go down the path of systems. With interoperability comes the challenges related to security as well. As we have more things plugged with each other, there's more potential threats. I was curious, maybe for starting off with Professor Bilal and Katan, in terms of how is the cybersecurity aspect of this topic, how much is that on the radar in some of the research that's happening? What are your thoughts on it in terms of dealing with it? And then maybe if the rest of the panel has comments on that too, that would be great. Without putting anyone on the spot, but I thought it would be nice to hear at the research level, because this is such a looming threat. How is this on the radar, and what are some thoughts on how we can deal with it collectively?
Yeah, so I think I can talk a bit about it. So in terms of especially with this cyber physical infrastructure that is coming in, and more connected vehicles bringing in on the roads. On one side, we want to make sure that the privacy of the passengers in the vehicles, they are maintained, but at the same time, if you are making these vehicles anonymous, then there are different threats that could be brought in. I'm not a cyber security expert, but attacks like Sybil attack, and that could actually clog our urban roads, just like the kind of attacks that are happening on internet with routers and so on. I think there's definitely room for those sort of attacks happening here as well. And I think while we are making our infrastructure, especially intersection level, more and more intelligent, we should also look at bringing in these defenses against such attacks as well. These attacks and defense, they have been very well studied in network security domain, and we should get some lessons from them and use them here as well. So that's my 2 cents.
Yeah. So yeah, I don't conduct any research related to cybersecurity and transportation, but I have seen that as emerging trend, and few researchers are even applying blockchain for transportation research because of its capabilities to incorporate the cybersecurity issues. What we do is a little bit more the resulting issues related to resilience and vulnerability of the transportation system, because they are a little bit these are the impacts of cybersecurity, of cybersecurity breaches are less reliable or less resilient system. I think we need to work more as an interdisciplinary teams, and we need to work more with researchers from computer science and software engineering, because most of people in transportation are in civil engineering, and without working in teams, we cannot really advance the research in this area. So I don't think much is done in Canada related to cybersecurity and transportation, but for sure there are lots of needs to work in cybersecurity and transportation.
To what degree is for example, the research that's happening in other departments, in the computer science and telecom, etc., how plugged in are those efforts into some of the research that is happening on your side, and is the right level of collaboration happening, because these two fields are so interconnected now, and do you think there is room for more?
Yeah, so I have give you an introduction about this CREATE program that we're doing. It's really multidisciplinary, I would say. However, interdisciplinary research takes long time to be established, because it takes long time for interdisciplinary dialogue to take place. So we are working with researchers from computer science and computer engineering and logistics and so on. And I think this should be we should be working more and more interdisciplinary. And also, it's also the composition of the team. So for instance, we try now to have really diverse group coming from different disciplines. Our students are not only coming from civil engineering, we have students from computer science, and especially because I think this area of research, especially network research, is so much more advanced in wireless networks and in computer networks. There's lots of room for cross-pollination of ideas, and bringing some novel ideas from different disciplines to the transportation.
Mm-hmm.
Homayoun, can I just jump in with a CIO's perspective on this? So, I mean, I would say that the cybersecurity risk for cities is extremely high for governments. Infrastructure is a massive target as it stands, and existing technologies are full of vulnerabilities. We talk a lot about the convergence of information technology and operating technologies, and largely in the public works engineering realm, we focus on operating technologies like SCADA systems and power grid systems and traffic management systems and fleet management systems. And in the right now, I think in the world of where IT meets OT, there is a sort of coming together of worlds where the CIOs are now working more with the city engineers, if it will, in my experience, to try and remediate a lot of that risk. But I would say that many jurisdictions are reacting, and that the threats and the actors that act against bodies are ahead on their thinking. I think when we start to get into these, again, metaverse-esque worlds, or worlds where we rely a lot on these models to make decisions, where the use cases are simple, it will be less of a threat. But where the use cases start to integrate, you know, traffic management with vehicles, with maps, with environmental, with sensors, with weather data, with all sorts of other things, real-time traffic flows. Your Googles and your MasterCards and your Visas have real-time information about the movement of humans. Once we start to expand our models to include all of those different data sets, it will be very difficult to get everybody onto a single paradigm for managing cybersecurity. So I think what we need to do is, as we build it, we need to think about it as we go. You know, again, like embedding it as opposed to right now where it is not embedded within the discipline necessarily.
Yeah, Mark, you had a comment?
Yeah, just something to add. I think something. This is a hugely important area, by the way. This is massive, and I think that when I was saying earlier on about the ethics side and needing to build this whole thing on ethical foundations, I think in exactly the same way it needs to be built on secure foundations and security foundations. And I described the whole thing as a kind of a socio-technical change program. You know, with both the social side and the technical side, and I can kind of see in some ways these dual foundations of both ethics and security in some way mirroring the socio-technical. So the security foundations are massively important for sure, but there's just a couple of clarifications that maybe I'd want to make. And the first one is that when we envisage this ecosystem of connected digital twins, what we're not thinking is one massive model of everything. We're thinking about federation, and the thing that makes the connection is shared data. It's data shared across organizational sector boundaries. So what's important there is that only the right people get access to the right data. And so the access and security protocols are really key. And I'd point out that not knowing stuff also points to insecurity. So it's kind of, we need to get this right, and just kind of, I should use an expression I've heard, is obscurity is not security. So actually not connecting stuff up doesn't mean it's necessarily more secure. And then the third thing I've just underlined is that in the UK, the work that we're doing on federation is actually being led by an agency we have called the Centre for Protection for National Infrastructure, and so it really is having security built in from the foundation upwards. This is a matter of national security, so we have to get it right.
Yeah, no, that's a great point. And you know, thinking of the comments on role of government that you had mentioned, Jesse's comment about talent, all of those comments tie back into the cybersecurity and the security issue, because we need talent in that regard. Government has to play a role in that regard. It's all connected at that level. Rafael and Cyrus, before we leave the cybersecurity topic, did you have anything to add?
If I have one thing about government, government is a big kind of, we kind of put all the governments in one bag. And I think that's one of the risks that we have in Canada, is that we don't really have a national strategy kind of towards digitalization. So what we have is some kind of, I will say, kind of discrete events or grants or programs here and there, but we don't really have a common strategy. I mean, the Smart City Challenge was one example, but after that happened, what I know is like many of us just went on to do some other things, but there wasn't really kind of a capacity building there. And the problem is the governments that it works in Canada, cities are a weak from a government that deliver most of the services. So we're really challenged to do some advancements without kind of some sort of a formal structural support from some of the higher levels of government. So it's going to be difficult for us as cities to deliver some of these things and think about all the layers of complexity. I think cybersecurity is a critical one, without having a common national strategy that supports some of the, not just kind of support in terms of like abstract support, but with funding support. digitalization efforts. So that's going to be a bigger conversation that needs to happen at some point, I think, with the feds and the province, because I do think we are, that's where we're failing right now in Canada. I'm not saying that there's not some advancements, but if we don't build a clear national strategy, it's going to be very difficult for municipalities just to advance these by themselves.
Yeah, I think I would concur there. And I think when you look at some of the complexities of the services that are delivered at a municipal level, you know, I think the analogy I would give is like everyone's very familiar with funding for infrastructure. So like bridges, community centers, at least in a municipal context, you know, upgrades to parks and trails. But if you think about, you know, cyber or digital infrastructure, I don't see it. It's a completely different area and nobody seems to have, you know, ownership of it. You know, we talk about connectivity and all these network requirements and IoT and sensor technologies, but again, that digital infrastructure funding, you know, from an infrastructure build perspective, whether it be infrastructure Ontario, infrastructure Canada, those pieces I just see as needing a more robust support to build the maturity at all levels of government. That would be sort of my feedback to complement what was already been said.
Thank you. I know Yannicka turned on her camera. It means we're about to run out of time. I wish we had scheduled 2 hours for this, but I know everyone's busy and taking time away from their busy work days. I won't get into this question because I need to give the baton to Yannicka, but there is a question about the use of digital twins for network planning and resilience. And I think that is really, really, really important. And some of the work that the UK is doing really ties into that in terms of flood. You know, one use case was related to flooding, which we in British Columbia know how that can impact our transportation infrastructure. So that is something that we can maybe through any follow-up questions and through Yannicka maybe share more information on. But that's a good segue to closing this off, was that the vision for this was to carry this discussion on into the ITS Canada conference when it happens next. So, you know, on that note, Yannicka, I'll let you elaborate on that a little bit and any closing remarks that you have.
Yes, so it's a fascinating topic, and I learned a lot, and I thank you everybody for your contributions. There is going to be a part 2, maybe a part 3 to this conversation as we move forward. ITS Canada annual conference is coming up in May, and the plan was to have sort of like a part 2 of this and to maybe focus on the environmental impacts that the digital twin can have, and that was based on the conversation Homayoun and I had early on with respect to the recent climate disasters, right, that have occurred in British Columbia, if we want to talk about the Canadian perspective there. So I actually don't know if you can still see my screen. Yes, okay. So I wanted to sort of close up with ITS Canada's annual conference is coming up. It's also our 25th anniversary in Windsor, May 4th to May 6th. For all the details, you can visit the ITS Canada 2022.ca website. Also, the ITS Canada Awards submissions are due on March 7th. Details also can be found on the website. And I would say that there is so much more to this discussion, and I don't think all questions were answered. So, Homayoun, I think you and I will take away the questions, review the questions, and then with permission would email those to the participants who were here, who joined us today. And I very much look forward to probably have another follow-up discussion, in particular the talent skills that Jesse talked about. I think at the upcoming ITS World Congress in LA, Los Angeles, I'm going to work on a session submission where we talk about talent skills with respect to digital twin and also transportation. So there's like a discussion needed on that particular topic. And yes, I also would like to see ITS Canada facilitate a discussion at the national level with the provinces on a potential national digital twinning strategy or framing strategy. That's something that I will take away with Homayoun and see once how we can facilitate that discussion at a separate event as well. Thank you, everybody. The recording of this will be posted on the ITS Canada website, probably tomorrow. Once that has been completed, you will be receiving an email from me. And also, with everybody's permission, can I potentially share contact details of all our panelists? But I would like your permission offline to receive that for anybody who has any follow-up questions. Thank you, Homayoun, for wonderful moderating that you did today. Mark, thank you for staying late. I know you're 5 hours ahead, well, at least as it is to Toronto. Rafael, Cyrus, Bilal, Lena, and Jesse, thank you, and thank you, the audience. Have a great day.
Thank you very much. Thank you. This was very good. Thanks for your time, everyone.
Thank you, everyone.